IoT systems faces significant security risk, which can disrupt services and even endanger lives. The lack of standardization and regulation across diverse IoT devices increases vulnerabilities and attack surfaces. Key vulnerabilities include weak authentication and authorization. IoT devices often lack proper authentication mechanisms, making it easy for attackers to gain unauthorized access. Weak authentication leads to data breaches, device hijacking, and network infiltration. Common vulnerabilities include hardcoded passwords. Many IoT devices come with factory set passwords that are easily guessed or widely known. Lack of authentication. Some devices allow connections without verifying user identity, leading to unauthorized access. Weak passwords. Users often use simple passwords, making them susceptible to brute force attacks. Backdoors. Some manufacturers leave hidden access points that attackers can exploit to take control of devices. Some mitigation strategies include strong password policies, avoid default hard-coded passwords, and enforce strong unique credentials. Mandatory authentication. Require authentication before devices can access the network using multi-factor authentication. Zero trust security. Continuously verifying device identity before granting access to the device. Insecure software and firmware. IoT devices require regular updates to fix security flaws. However, many lack mechanisms for updating, leaving the devices exposed to vulnerabilities. Attackers exploit outdated software to install malware, hijack devices, or disrupt operations. Common vulnerabilities include failure to update. Many IoT devices lack built-in mechanisms for automatic security patching. Outdated components. Legacy hardware and software often lack security updates, making them easy targets. Outdated firmware. Without firmware updates, devices remain vulnerable to non-exploits. Mitigation strategies include regular updates. Enable automatic security updates for firmware and software. Firmware validation. Implement secure boot mechanisms to prevent unauthorized firmware modifications. Manage outdated components. Replace and monitor outdated hardware or software for vulnerabilities. Communication and security risk. IoT devices are constantly connected to networks, making them vulnerable to attacks that exploit weak encryption, unsecured communication channels, or misconfigured network settings. Attackers can intercept sensitive data, disrupt communications, or inject malicious packets. Some of the common vulnerabilities include unprotected network services. Open ports and unencrypted communication allows attackers to intercept or manipulate data. Internet exposure. IoT devices are directly connected to the internet without security controls, becomes easy targets. Unprotected interfaces. Weak security on APIs or cloud-based services can expose sensitive data and functionality. Some mitigation strategies include network security measures, use firewalls, transport layer security / SSL encryption, and intrusion detection systems. Network segmentation, isolate IoT devices to minimize attack spread. API security, authenticate, encrypt, and validate API interfaces to prevent unauthorized access. Supply chain and manufacturing vulnerabilities. The complexity of IoT supply chains introduces security risk at multiple stages, from production to deployment. Attackers can introduce vulnerabilities through compromised components, malicious firmware, or weak cryptographic mechanisms. Some common vulnerabilities include supply chain vulnerabilities. During manufacturing, attackers may introduce compromised software or hardware components. Poor key management. Weak or improperly stored cryptographic keys can be exploited to decrypt or manipulate communications. Some mitigation strategies include cyber supply chains best practices. Conduct security audits on vendors and enforce secure software development standards. Key management. Implement strong cryptographic key management using public key infrastructure. Poor device management and oversight. Many IoT deployments lack centralized monitoring and control, leading to weak security postures. Outdated, misconfigured, or rooked devices can become security risk without proper oversight. Common vulnerabilities include poor device management. Devices remain exposed to cyber threats without proper monitoring and updates. Data management issues. Large-scale IoT networks generate massive amounts of data, challenging security management. Lack of standardization. Different manufacturers use varying security protocols, making it challenging to enforce uniform protections. Some mitigation strategies include security by design. Integrate security from the development phase and conduct regular assessments. Artificial intelligence and machine learning. Automate vulnerability detection and anomaly detection. Staff training and education. Educate users, developers, and managers on cybersecurity best practices. Physical security threats. Unlike cybersecurity threats, IoT devices can physically be accessed and tampered with. Attackers can manipulate sensors, extract sensitive data, or damage devices to disrupt services. Some common vulnerabilities include physical vulnerabilities. Devices deployed in remote or public locations can be stolen, modified, or vandalized. Mitigation strategies include physical protection measures. Use tamper-proof enclosures, surveillance, and geofencing. By understanding these vulnerabilities and implementing these mitigation strategies, IoT systems can significantly enhance their security posture, and minimize vulnerabilities.